Everyone, hope you guys are doing well. So we're restarting from where we left off, and let's let me check if noise cancellation is set. Audio capture, printers. Okay, yes. Okay, so we were with Swift views, so we'll just complete some use of view. So we will be refreshing about a bit about views, and then we will be going ahead. So then what is a view? A views, so basically what we do in Swift is we have views and then we apply modifiers to them and change their behavior. A view is basically an element. Now views are so to organize the views we use containers. So there are different types of containers. Structs are views too. They are views that can have modifiers applied to them. Which stack is the most used view? There is another which is a stack. Another stack is Z depth. Swift view also offers a layout, so we can do it a grid view as well. A layout. So is he saying? So basically, if you see, I have so this is yeah. So this is the big one is the H stack. In that I have two H stacks. This is one, and then the screen is split between these two. Then I have, so this is direct H stack. This is a small H stack inside a V stack. It's common programming to express a hierarchy, parent and child relationship in this book. So we have the parent is the H stack, and then inside I have V stack, that's child views. Some modifiers can be set on the parent, and it will also apply to the children. Some the parent text does not okay in this example. So he's saying that when we apply to the parent, it will apply to the child. In this example, the font is set on the parent and the child views it. The parent text does not use the font size because it can be set on the parent view. It will apply to the children. The font is set on the parent and the child views use it. However, the parent text does not use it because the font size is kind of overriding it. So this is a text view, and then I have V stack as the parent. So in the parent I have, so basically saying this is like this child is not getting affected. That's what he's trying to say. All the children sent on the parent and the child views use it. The parent, so the font size is going to be applied on the yes, it's applied 30 points on the waist stack, whatever is inside the waist stacks, but this is overriding. So whatever is overriding will be okay. Let's just write down. So like in a parent-child relationship, if modifiers, okay. Before I go to modifiers, there's something called as modifier hierarchy. So what is, let's have this set up now. Just give me 1 minute. Yes. So although you haven't specifically started with modifiers, I need to have a hotkey set up because every time I need to turn this thing on. Okay. So then the modifier hierarchy. So suppose I have two things, right? And then so this is child view and this is parent. So what he's saying is if certain properties are going to be inherited, child view inherits certain modifiers. That is what he's trying to say. Okay, and when set on parent, now understanding syntax. So where it starts, I have content view. Okay, a struct is a group of related properties and functions. This is the name of the screen view. Utils. No, this is basically we are conforming to the view protocol. The body property. Yeah, this is we have already discussed these things, so let's not waste time. Yeah, let's go ahead. The view. Yeah, you remember by default the preview is going to the preview contain a kind of center set. Then a body is a property where get and return. We have seen that struct swift with property getters. So you have a get. Okay. Opaque types. Now what does this because here we are not specifically mentioning is an associated thing. We're going to return some type of view. Then opaque types. Okay. View container. So far, okay. Not needed. So let's start with the title. I'm starting with the title is so first thing I'm going to do is text view. If you want to make it larger, you can use the font modifier. You can set. Let's get rid of the spacer and then this one. Let's have this big. When we use it, let's text and then why did it and so the moment I refresh it, replace the first time it takes time. Waiting to reconnect. Yeah, it will take time. Let's see. Okay. Yeah, hi. This is text. Now let's so now the container, the first container we are is going to use vstack. So if you see it has alignment, spacing and content. Now spacing basically will say how the elements inside are going to be spaced. So vstack, remember these are optional, right? So you can do space 20 and then let's have this is s, yeah, and then so all of these are going to be spaced 20. So if I do, and then the next one is the text and put in a comment. This is paste 20. Perfect. So yeah, so the first modifier is on font. Either you no, this is an optional, right? Okay, so the thing is, these are nested structs. So I'm going to say either I pass. This is an optional. So you do large title. So the size is in place. That's all. Nothing more. So then adding the subtitle. We haven't let's did we talk about nested? We talked about those, right? When there is a nested struct, for example, I guess in dot. Yeah, these are nested structs, I guess. So it's dot font, and then again you do so let's just copy. ChatGPT is always open, so just come here and paste. Is this nested structure? No. So why do we use dot large title? Why dot? Okay. So now let's see the font struct. So see, the thing is, okay, so modifiers will basically have enums passed to it because it will okay, let's start with modifiers. So first is visual modifiers, right? So the way, okay, let's have this. So there are different types of modifiers. So layout modifiers, these are going to affect the layout. Visual affects the visual, as in interaction is affects the interaction. Then we have content modifiers, which will affect the content. The first is layout. Then we have animation, provides an effect to the animation. Then environment modifiers affects the environment, and view modifiers, which affect the view. So first is visual modifiers. So I have foreground color, sets the color of the views. This is about content. Background sets the background color of or view behind the content. So if you see what he's trying to say is, so like so this is the button, this is the content, and the behind portion is the background. Foreground is content, this content. That's what it's trying to say. And then we have corner radius rounds the corner, so whatever you do, it is going to be going to mention these corners. Let's not get okay. Then okay, we'll just go through like what these are, and then when we are using, we'll then have corner radius. So for example, if you have a rectangle, right, and you want to curve these edges, then you can use corner radius. Shadow, this is when this suppose and you need some shadow effect. So again, this is all visual things. Suppose this is there, and then you give it a color, and then you need to blur it. So then you have this. Okay. Now we have something. Okay, so let's have a page and see something. Some modifiers and enums. So remember, modifiers are going to work on one views, right? And then when we have so when we pass in so when we say this is going to be, it is a struct. Okay, why can we change? So this is, our views are struct, right? And then when we are chaining a struct, instead of chaining a struct is because structs are methods and are designed to return a new instance of a struct. Okay, so let's see what is going to do is, so this, oh, remember there is, first let's see what is this chaining. That's the name. So for example, if you say this is a struct and then dot set width, so first is I'm going to create, okay, let's have a struct. Suppose I say this is rectangle, this is, and then I have height, this is double, and I have width, this is also double. Then I have a function which is a set, then I have, okay, then I say I have function 1 which is set width, and then I have function 2 which is set height, and then I have function area. This is going to calculate area. Then I close the parenthesis. Now I'm going to create an instance of rectangle. So I'm saying rect is rectangle, and I'm passing in width, and width is 10, height is 20. So when I do this, this is going to be 10, this is 20, and now I'm chaining this dot. Missing func1, and I'm passing in 15, and then so self dot the method returns a new instance of the struct. So from let's no I have, and then inside style. Okay, so it's so the return values is self, right? So I'm going to okay, this has return. This is a return self. This also has a return. So but the original one will remain as it is, right? So I've changed, and now suppose if I pass in this is like basically methods returns a new instance. So when I do rectangle width height, so no, but initially there is where is the return? This is going to create instance of the struct. Okay, creates an instance. This is called initial. Okay, then what I'm doing is so so I've created the instance of the first, and then this is going to so but this is not returning anything. What am I returning? You're creating, yeah, in the constants is an instance, so I have an instance. So now that rect is used to instance. A rect cannot be modified, meaning the properties of the instance cannot be changed. Okay. Now then, what is happening to this? So this thing, why does it happen? This, there is no struct return from first. Okay, the chaining works because why? Returns a new so this is dot so initially I sent 14. Okay, so the way to access method is you need the reference of the struct. So when I do is this style set font size okay. No, where am I? Yeah. So now this is, so remember this is going to return a font size of 18 and then capital self. So self returns equals to the type of the struct. It is so returning. You can use self as a return type for a method to indicate that the method so when I do return self do I create a new instance or return the original create self when I return. So for example, in most cases there are value types, right? So whenever we do, if you want to work on the original, then I'll have to use something called as mutating. Okay, so that self so if I go up, so I'm returning a new style struct which has, if I see over here, if you go, yeah, if you go over here, where was my first code? First, yeah. So if I do, oh no, still right. So what is oh yeah, so now this is going to return a new, but then how is set with retain? If this returns a new struct, then how is the value remember? Okay, so see, this is going to be 15, this is 25. Now this is saying, so this is width and height self. So initially this is going to be this is going to set height. This set width is going to make the width 15. And what is this sense of that height? What is this self dot height? So self okay, so this is a Swift concept. Let's see something about capital cells versus small cell. This is, and let's see about mutating functions also. When do we use the mutating keyword? Okay, let's skip UI. Are we on structs? No. Closures. This is set. Okay, structs. Okay. We have seen on this, right? Designated. Extensions also we have seen. Okay. Now let's see. Self versus capital self. This is something that we need to learn. So self in Swift, what does self does? Self is used to refer to the current instance of a class, access the properties within its scope. It also shows specific purpose in subscripts of the current instance. So let's talk about self. This is S is small. Returns current instance of a class. No, refer is not returns. No, it shouldn't be returns. Refer, sorry. So refers to the current instance struct class and enum. Okay, then for example, okay. So now there is one thing. So we said struct value types, which means copies are passed. And original is not affected, right? What if you want to do something to the original? We know shift structs are passed by value. No, we know that copies are created of the struct when assigned to variables. What if we want to modify the original struct such that all other struct are also modified? Okay, I use a shared instance. Okay, the shared reference. Now, okay, the use of mutating keyword. Now I need this. Is use modify properties because they're immutable. But any keyword allows. Okay, so there is one problem that happens with structs. So I have a rectangle. So when I do rect dot size, a new struct is going to be created that has a value 2, right? Now the thing is, okay, so problem is when we button I do red dot. I'm calling this red resize. So and we creating a new copy. Okay, so new copy is generated. No, we got a mutating method. When we have conflict, like by default, it should create one new copy without mutating. We will get error as to it won't know whether it is the copy or original, something like that. This way ensures that each Java struct is independent. Okay, now when you call a method in a struct, it treats the instance of as immutable, even if the instance is just to ensure that you don't accidentally modify the instance. Also, yeah, that's what is going to happen. So, um, so we need some mechanism to identify if it is a copy or not. There's a conflict. So that is like Swift structs are treated, right? New copy is going to be generated there. Okay. Is this visible? Need some mechanism to identify if it is copy or original. Um, mm, So for example, this is a struct resize rect and have two parameters rise rect and something. This is something which has certain parameter. Oh, let's not have it as some variables. Variables A, variable B. Let us create resize rect is select one is resize rect. So when I do this, so this is going to be this resize rect one, and then when I call it again, say resize. Can we move this from this text? Second. So I have so now below line I do something like resize rect 2 is equal to resize rect. So then a new copy is generated. So I have one more, and this is referred by resize rect. The problem is, what if I try to modify it? So what if this is something which can be modified? So by default, if this weren't mutating, so if I trying to modify instance, right? So you need to use the self instance in place. So I'm going to say this is my current instance, but then copy optimization does not know which instance. So mutating, I say is updated directly. That's what is happening, right? To avoid this ambiguity, we use mutating. Okay. So now let's come to our where we were to the original one. So where we were doing chaining. So if we say by that logic, where was rectangle? Okay, so what is this capital self-indicate? What is this? Insert? No. When I'm doing capital self-return, there is some difference. The current instance. So when I do self, okay. This is self with capital letters. Sorry. Self with this is capital. So then now this is going, this means the type of current instance. Perfect. No, because in return I need to mention, right? So let's go up. Where we are? Okay. Let's say this is, oh, this is not. So, you're chaining, right? Some. Okay. I'm doing style. No, this is mutating. Let's go. We were without the mutation thing. Yeah. So then first is we are going to return this, and then okay, and then I'm saying this is text. Okay. Now return a new view on the modif. So, but then text and dot set font size. So what happens about the remaining parameters? I think. Copy will be given, right? When we do text dot this is text creating a new copy. Yeah, so this is going to return a copy. So okay. No, wait, oh no, I'm not in class. This returns text dot style. This is going to return a new copy and text dot style. This function is getting, and this is going to return. So what if in this I have some parameter which updates? Okay. Does it kind of pass the previous instance as well? I guess. So yeah. The self refers to the struct which is being passed when the self refers to its type as another changing struct will need it. Yeah, there you go. So when they do style dot set on size self is now referring to style. Is that true? Yeah. So instance, which is this call. Oh, it appears. Yeah. As if this the original style struct, but copy of style is being passed. Yeah. Okay, guys, that's all for this lecture. See you in the next one. Thanks. Bye bye. Take care.